Great. Thanks for joining us. We're here to talk about building cross-platform apps. My name is Rex Hansen. I'm the product manager for ArcGIS Runtime, one of them. I'm joined by Mark Baird, who's a product lead for Runtime SDK for Java and Android. Morten Nielsen, who is the development lead for the Runtime SDK for .NET, and Michael Timms, who's the development lead for the Runtime SDK for Qt. Just a quick agenda, just to kind of get you guys a lay of the land of what we're, really a roadmap for what we're actually going to be doing in the next hour. First, just a brief cross-platform review, just to kind of get thinking about those different, concepts or ideas around building cross-platform applications and what you need to consider and think about when you're choosing a platform. Then we're going to dive into specific benefits associated with individual development platforms, both so for Java, Qt, and .NET, and working with the Runtime SDK with those options. So first thing we actually want to talk about briefly is that we've got a number of there's two different strategies here that you can consider when building out client applications. We have a native strategy, right, which really offers the best option when you're looking at building out managed API experiences, developer tooling that supports device integration, and building out solutions that can work with the sensors and capabilities of a device that work both connected and, most importantly, offline. Right? So offline is the critical piece there. And being able to require that sort of native, immersive feel and look and feel and experience that you'd expect with a native application. So the Runtime SDKs are designed to be able to support the development environments that enable you to target these native experiences. Now, web strategies use other technologies that are designed to be powered by browsers, generally. Whether it's a browser control or it's a browser application, and they're powered by a variety of different specifications like HTML, JavaScript, CSS. They're usually hosted in some manner and available in a connected workflow. Quite flexible for use cases where you want to be able to provide an application that's designed to be always connected, whether it's desktop or mobile, and you need to be able to provide an application that's available pervasively. Right? So generally public applications where you're reaching out to a community where there isn't necessarily a specific workforce for which it's targeted in general, or you're looking at building out maybe operations dashboards or command and control situations where you can actually leverage some of the browser capabilities to make the distribution of the application, which will always be connected, more pervasive. So one of the keys there, of course, you can use the ArcGIS API for JavaScript, which is our web technology that Esri offers to be able to build out solutions on that. Now, granted, both of these technologies are still operating within the ArcGIS platform, and so they're still working with a common definition of a map and layers on a variety of specifications that enable you to build really a common experience and then be able to distribute that experience and utilize that within your client applications. One thing that really differentiates them, or the two things that differentiate them, is the developer experience and the ability to take your data offline and work with data and operations offline. So first, just some general considerations here, benefits and challenges associated with cross-platform development. Obviously, one of the benefits is sharing application code, right? The ability to write your code and then share it across multiple platform targets. There's a benefit to being able to refine that process without having to maintain or manage lots of code for different platform-specific situations. Generally, what this does is that if you need to partake in a cross-platform solution, you're going to be organizing your application, let's say in a different pattern or workflow like MVVM, where you're going to be organizing your model and your business logic to be separate from your view, and so that you can better structure and develop and enhance that application and target those locations within your application that can be shared or can use shared code. Obviously, if you're looking at building applications that target multiple platforms and sharing a lot of that business logic behind the scenes, you can target more platforms, right? So a lot of the business logic that you might build to target an Android platform might also be available to be accessible for iOS or for Windows or Linux or Mac, depending upon which technology you choose. Of course, the challenges associated with this are debatable. In some cases, some of the developer environments that are offered, native development environments, provide you with a more immersive, or it's easier to build a more immersive or an application that feels like it belongs on that device or platform. In some cases, it's easier to build an application that looks the same on every platform. It really depends upon which one you need to take advantage of. Obviously, there are idiosyncrasies associated with different platforms, right? So there is an accommodation that you need to account for in most cases, you're not really going to be able to write it once and run it everywhere. There are going to be some situations where you do have to account for different capabilities. And so something to think about. Obviously, if you're targeting more platforms, it involves more testing, right? So you need to be able to test for those idiosyncrasies to determine if there's something that needs to be resolved or issues that need to be fixed and accommodated for. And of course, there's a development cost, right? So you want to be able to not just target a platform, but be able to continue to maintain and build and enhance support for that platform. Obviously, this could be a benefit as well. So if you're not building on different languages or in different developer environments, you've consolidated that into one developer environment. You might be saving on extra development cost or having to maintain a separate development team for a different targeted platform. So this could be somewhere in the middle, basically here. But inevitably, if you decide to target more platforms, generally there's going to be an additional cost. Using a cross-platform technology is an attempt to minimize that cost, basically. So the pivotal question here is which one's right? Which one's right for you? Which one's right for me? And the key here is that you really need to understand expectations of your user community. Who are you targeting? What types of platforms do they intend to use, and what do you intend to support? So once you have a sort of a lay of the land as far as what you need to be able to support with the applications that you're building, you need to be able to evaluate how you'd like to structure the application that you're building and which technology you'd like to choose. And that means that you might need to educate yourself or your team, or you might need to build a team that knows a specific platform or has a knowledge in a specific platform to be able to target the platform targets that you need. So the key thing here is that if you have knowledge in a specific area or technology and you want to be able to leverage that technology to target multiple platforms, that's ideal. That means that, for example, if you're a .NET developer and you've been building Windows applications and you've been building in C# for years and you want to be able to support other platforms that .NET supports in a cross-platform solution, such as Android and iOS, then you might need to learn a little something extra, right, to understand how to deploy or how to target those platforms. Granted, you already have the foundational knowledge in C# and .NET, so it's basically just some extra work that needs to happen. If you choose to work with maybe the native development environment for that specific platform, it might require sort of entering from the ground up, right? Learning a brand new developer experience. That could actually take a lot of extra time. So being able to leverage your existing knowledge is critical, if you can. Of course, there's multiple players in this market, and so whether it's for Java, with Oracle and Google, or you're working with Qt and the Qt company, and or Microsoft and their .NET platform, there's a variety of players that are sort of vying for these different cross-platform experiences. So with that in mind, what we've built in Runtime is a set of really native components. These are built in C++. Those components are then available or built for individual target platforms, and then they're shared and exposed through a set of developer SDKs. These developer SDKs are the top tier in this diagram, and they provide a managed API experience for different developer platforms. The key here is that most of the business logic associated with Runtime is actually resides within our core, our common core that's shared across these different developer experiences. Now we're building on top of some of the industry industry standards for cross-platform development, and so we've basically decided in this session to target Java, Qt, and .NET as really our cross-platform offerings, because they do offer the ability to target multiple platforms, and we're building on basically the standards offered by that platform to be able to take advantage of those cross-platform capabilities. So with that in mind, I'm going to hand it off to Mark, who's going to take us through the Java experience.
Okay, thank you, Rex. So let's just take a look at this from a Java point of view. Some people love it, some people hate it. Not many, fortunately. And if you believe the splash screens, 3 billion devices. It's out there quite a lot. So it actually makes it to be a very natural platform to build once and deploy to multiple platforms. Now, the 10.2.1 release of Runtime is really aimed at Windows, Mac, and Linux. So we're really about deploying applications to desktop platforms. So we don't cover mobile platforms, it's just desktop. And we're about here writing JavaFX-based applications. Now, as Rex's slide demonstrated, the architecture we're running on here is actually based on the runtime core, but because it's a Java application, it needs to run inside a JVM that needs to be installed on your machine. So the typical development workflow you would go through is you would choose one of your IDEs of choice. IntelliJ, Eclipse, and NetBeans are popular IDEs, but there are many more. And you would write yourself an application and then compile that into a runnable jar file that you would then deploy into your platform of choice. So and that would run in Windows, in the JRE, as it would do in Linux and Mac. But because we're not writing pure Java applications here, you also need to deploy, alongside the jar file, the compiled runtime core library that comes with the SDK. So if you want that to work in a Windows environment, you need to include the DLL file, or if you want it to work in a Linux environment, you need an SO file, and then there's a dilib for Mac. And actually, if you make yourself a deployment which has got all three of those binaries included, then you can actually make yourself an application and you can give to a customer, and it'll work on Mac, Windows, or Linux. So that's quite a powerful story. So what are the considerations for writing cross-platform applications for Java? Well, I'd say generally it does just work. JavaFX is actually very consistent in its behavior on all of the platforms. There are small differences, but these differences are actually quite small. So if I draw your attention to the two application screenshots I've got down in the corner of the screen here, you can tell which one came from a Windows machine and which one came from a Mac, for example. But beyond that, they display and render in exactly the same way. So they look like they're designed for the platform that they're actually running on. The main thing you do need to be a little bit careful of is when you're working with file-based systems. So if you were to have a file you needed to access in your application and you're writing a Windows application and you hard-coded in C:\users Windows style path to a geodatabase that you're wanting to access, you shouldn't be surprised that that wouldn't work in a Linux environment because the path is formatted very slightly differently. So how would you deal with this in sort of a runtime environment? Well, I would, to make it easy for yourself, actually make sure that the data you're trying to access is in a path which is relative to the location of your executable jar. So you would reference it using a /. You're picking it up from the relative location that your application is running from. And then // and \/ are varied between Windows and Linux. If you use a /, Windows accepts that too, so you'll get away with that on Linux and Mac as well. You can use environment variables, so if you can't position the files that you're looking for in a position which is relative to your application, then environment variables can be read and consistently used on the three different platforms. So I'm going to switch over now to Eclipse to take a look at a simple application that I've got running in Java. So I'm going to fire this up, and it's a very straightforward application. I'm showing a 3D scene here, and I'm representing a 3D point, which I'm symbolizing using a 3D collada symbol. So this collada symbol is actually represented by a file that describes all of the vertices and the textures on this in a file. So if I close my application down, just draw your attention to the line of code where I'm picking up that file, you'll notice that I'm picking it up from a /samples data location, which is going to be right next to the position of the runnable jar in my application. So what I can do now is I can actually create a deployment for this, which I can then put onto one of my other platforms of choice. So I've compiled up this jar file that I've been running on my Windows environment here, and I'm going to switch over now to my Mac to show this working. So as long as Morten hasn't sabotaged this whilst I've been working on the other machine, this should actually work. So you'll notice here in the root of my folder, I've got my runnable jar file, and then you'll see next to that, I've got my samples data that contains the collada file, which is representing the model that I want to deploy which I want to render in my application. Putting me off. So because this is going to work in any environment that I actually run it on, you'll notice that I've got an SO file there so that it'll run it in a Linux environment. I've got the dilib, which of course is going to be read with the Mac that I'm running it on. And then you'll notice that I've got a DLL file here. And I've actually got a 32-bit version of that as well. So we could run this on Windows 64-bit or 32-bit. Surprisingly, there are 32-bit users out there. So if I just double-click on this jar file, you'll see exactly the same application that I was running in my Windows environment, but this time on a Mac. And it looks and works exactly the same. And there's very slightly different styling differences here, so you know this is actually an application which is destined for a Mac. So I'll just switch back to my slides now, and we'll just summarize. So each of us are going to sort of look at the advantages and disadvantages of each of our platforms. So I think the main advantages for you can just shut that. For working with Java is the IDEs, IntelliJ and Eclipse and NetBeans. They're all free, as is the JRE. So this is kind of the runtime environment you need to get from Oracle to run on your machine. So there's no cost associated with development or deployment, apart from the runtime cost, of course. The deployments can be identical for all platforms, so you can make an application that you can run on any environment that you run it on, for Linux, Windows, or Mac. But the JavaFX applications, they do style themselves for the platform that you're actually running on. Disadvantages? Well, I'm struggling with disadvantages actually, but it's worth saying that the app would not work if the JRE wasn't present on the machine. But there are ways around that. So there are enterprise deployments of Java that are actually very easy to do. So you can make sure that in your enterprise environment the JRE is there and it's up to date. You've got the latest version and all the security patches are applied to it. But you can also make applications which have got self-contained JRE installation. So you can just give an application which has also got the JRE embedded. So this is a little bit like Minecraft, for example. That's how they deploy their application. The main thing I will say is that we're not around supporting mobile applications. So this is just for desktop for Java. Okay, it's Rex.
Great. Thanks, Mark. Actually, while we're transitioning here, just a quick question. How many folks are using the Runtime SDK for Java right now? Anyone here? No one? Okay, so maybe someone will be using it after Mark's presentation, so it'll be good. We'll be checking back, right? Anyone using the Runtime SDK for Qt right now? You work for us, so okay. All right. No one else? Okay, so maybe after Michael Tim's fantastic presentation, we want some Runtime SDK for .NET. Oh, look at that. Yeah, it's good stuff. Okay, good. That's great, guys.
Sorry.
Okay, some good representation. Great. Thanks, guys. All right. How are we looking, Mike? Is it good?
Yeah, we're good.
Okay.
Thanks, Rex.
And on to Qt and Michael Timms.
All right, thanks, Rex. So I'm Michael Timms, lead developer on the ArcGIS Runtime SDK for Qt. We'll talk about cross-platform development using the ArcGIS Runtime SDK for Qt. But is anybody out there a JavaScript developer or an App Studio developer at all? No? So we've got, cool. So what do you get with Qt from the Qt company? You get this complete cross-platform experience in this cross-platform framework with pre-built binaries for the different kits, they call them. You get these out-of-the-box, ready-made UI elements, all these libraries and the tooling, all pretty much packaged that can run on your major desktop platforms. Over 1 million developers that are available. You got indie developers, corporate developers, lots of good work going on there at the Qt company. This large open source community, which is really great, so you can get visibility right into what's going on in the Qt community there and at the Qt company. And really, proven to code less and create more and really deploy everywhere, all from one tool and one framework using Qt. So platform support using the ArcGIS Runtime SDK for Qt. We've had these platforms for many years now, Windows, Linux, macOS, Android, and iOS on some of those different architectures. What I am curious to know, I didn't see very many people out there that we're using Qt at the moment, but Universal Windows Platform is available in Qt, and it's something we're looking into. And if you have any interest in using that with Qt, I'd like to know. And also any sort of like Linux embedded ARM environments, which is really Qt's bread and butter platform. We don't deploy to that, but I'd like to know if you happen to deploy to those types of devices. With the ArcGIS Runtime SDK for Qt, you have two APIs. These are two independent APIs, but they're both runtime APIs, so they look the same. They're just built on a different programming language. The first one being the C++ API. We support the two different UI frameworks, which the first one's Qt Widgets. This is your traditional desktop-based UI that many people still use, and a lot of app integrators still use widgets when they're deploying to the desktop platforms. Qt Quick is a newer framework UI, really designed to have this nice, easy to use, depending on the different form factor UI, especially for mobile platforms. You get this modern C++ language. You can use C++11 features. Fast performance, direct binding onto our C++ underlying core. The QML API, this is what App Studio is built on, and Survey123. The Qt Quick QML for your UI. So you're using this Qt Quick, a sort of JavaScript engine-based QML for your UI. You have this declarative language, and you're coding up most of your business logic in imperative JavaScript business logic code. Like I mentioned, App Studio and Survey123 coming in a soon release will be consuming this QML API from the runtime. I usually haven't shown this, but I know we get a lot of questions about JavaScript and kind of its relationship to the QML API. So I wanted to sort of show a code snippet here of what QML looks like with JavaScript and events. So you have this highly readable JSON-like CSS syntax that's really familiar to web developers, HTML5 or JavaScript developers. You can declare these different UI elements that are coming from the Qt framework, like this button, and handle those, what they call them, signal handlers. And when you're actually within the scope of these signal handlers, you're coding up an imperative JavaScript code. Because again, QML is just based on a JavaScript engine. You have this dynamic property binding, so whenever properties change, for instance here, map's property load status, as that changes, it's reevaluating to see if it's equal to the load status loaded enum, and then the button becomes enabled. And that's all you have to write to do that code because of the property binding that's being done in the QML engine. And then obviously we bring in the ArcGIS Runtime into the QML space. So what do you need to know to get set up? This is where you're a bit different from App Studio. You do need to get your compilers set up. Like iOS, you need your Xcode compiler. Windows, you need your Visual Studio compiler. That can be the Community Edition compiler. Debugging tools, Linux, you'll need GCC, and Android, you need to get your NDK and SDK bits, and you need to get all these hooked up into the Qt framework, into Qt Creator. A lot of the times it just sort of happens, but Android has some additional steps, which I'll show you in a minute. And then once you're set up, which does take a little bit of time, but we've got some good documentation on how to do that. Now you're writing the same code on all platforms, and you can pretty much build and run from the Qt Creator IDE, which is really my recommendation to use the IDE Qt Creator, because it'll run cross-platform on Linux, Windows, and Mac. And you can really design and develop and test all from this one tool and get the same experience. So that's pretty useful. So I'll show you just a really quick demo here for getting the environment set up. Here's what Qt Creator looks like if it came up okay. The additional step with Android I'm referring to is once you have the Qt framework installed, you drill in here to the devices, and there's this Android tab. And here's where you have to actually specify the location to your JDK, Android SDK, NDK, And Ant is deprecated. You can actually check this box to use Gradle instead. But this is an additional sort of setup step to tell it where to get your Android bits. And once you're done with that, here's an application that we're currently building on the Qt team called the Dynamic Situational Awareness app. And here it is running on Mac, and I'm running it directly from Qt Creator. I just hit that play button, it's compiled, and we run it from Mac, and I can play around with that and test my application. If I want to test this on other platforms, as I close that down, over here on the left side menu, we have the different kits that we can select. So I can just select Android, release, and say I want to run the handheld project that's in here. That's all I really have to do. Then once I hit the play button, this is going to ask me which device I want to deploy to. And typically, if I had my Android device awake, it would probably find it. Nah, that's okay. Typically, you'll get your Android device listed here. You'd select OK, and it would go ahead and deploy to your Android phone. And you'll be testing and debugging your Android phone just right from the same IDE using the same experience. So the same thing goes for iOS. I can just choose iOS, release, and run it straight from here. So now I have the application running on iOS, and this is really using the same code. It's the same application. This one has a different UI spin to it, where I can pull up my talk here of overlays, existing layers. And if I click on this menu button on the right side, you'll see I have a little menu that pops up from the bottom. So keep that in mind. We're going to exit out of that and go back to my desktop here. I think it's 3. Yeah, that's done. And when I run this application on the desktop, keep in mind that menu. We're going to see something different on Mac. When I run this, we'll actually see a little bit of a different menu. So here I've got my overlays, and when I click this menu, you see it didn't come up from the bottom, but I have this different pop-up menu. So we have a little bit of a different UI experience depending on which platform I'm on. That's not traditionally the way that Qt Quick controls and things work, but it is doable to do that, and I'll show you kind of how you do that. It's the same code. I'll drop into Qt Creator here, and this is our IDE, Qt Creator. And when that actual button was clicked in our mouse area, we have some logic in here written in JavaScript with if it's not mobile, it's going to open that vehicle menu. Else, it's going to drop in and open up our mobile menu. So we have the different menus. Here's our vehicle menu. And else, it's going to open this other one down here that I've defined as our mobile menu. So even though it's the same code, I'm actually calling them differently depending on whether I've detected I'm running on mobile or I'm detected I'm running on desktop. So some of that code that won't even execute on desktop. So that's how you would distinguish between the two. But most of the time, you're writing the same code and you have the same look and feel. But that was kind of one example how to make it different. Back into the slides real fast. Try to zip through this. Qt Quick Controls 2. This is Qt Quick Controls 1. So these are ready-made UI elements in the Qt framework. And these ones somewhat have a native look and feel, and they're built for QML, and they have a native look and feel for the platform. They have some limitations, and recently the Qt company has released Qt Quick Controls 2. Qt Quick Controls 2 do not have a native look and feel to the platform. And these are really the controls that the Qt company is doing a lot of work on. They're the ones that we use mostly, and they're probably the controls of the future for Qt. But you're not going to get the native look and feel with them. You're going to get these different styles that you can set. So you have this default style that you can work with, or you can have a material style, which is based on Google's guidelines, universal style based on Microsoft's guidelines, and a couple newer ones, Fusion style and Imagine style. Imagine style is based on like image asset images that sort of scale for your UI accordingly. But these controls are going to look exactly the same on no matter what platform you run on. So keep keep that in mind if you're looking for that experience where you want them to look like the native platform. Qt Quick Controls 2 is not going to get you that. It's going to have something that looks exactly the same on all the platforms. So here's a quick demo. I think we were kind of in here before, but if we look at the overlays, this is actually using material design. So you somewhat have this sort of material design look and feel, but you can see this whole DSA app almost has like a Windows look to it in a way. And that's just because you can style it really any way you want to in QML. And that's just sort of how, you know, most people do it, is just sort of style it how they want it to look, because you're not going to really get a lot of that native look and feel with Qt Quick Controls 2. Something really cool to point out is when you're using Qt Quick Controls 2 is the configuration file. So you can set up these different configuration options. Say, for instance, the material primary color. You see I had that grayish color as my sort of background for some of my toolbars. I can just change the color to a blue color simply by modifying the configuration file. It doesn't really look that great for this app, but it's just an example of how you would actually do that. So you can have your code reference your material primary style, and you just make that one color change in one location. So the Qt Quick Controls configuration file is pretty neat and pretty powerful. All right, our favorite section, QML limitations. With every cross-platform framework, you know, you're going to get limitations. Some of the ones worth highlighting today are some of the missing APIs that are not available in the Qt framework, period. That's because the Qt framework has this manual implementation of how they abstract out the different APIs that are available, say, for instance, in the in the Android SDK or in the iPhone SDK. So there may be some things that are missing. Like one of the big ones that we keep getting nailed on is no client-side push notifications API. So if you need push notifications, you're going to have to implement it yourself because the Qt framework doesn't have that. No access to Android photo gallery, inter-app communications API, things like Apple AirDrop. You're not going to get an API for that unless you drill down and you actually start writing some Swift or Objective-C code. QML is really designed for UI. We have a QML API, but it's designed for UI. So some of the C++ APIs that are in the Qt framework, like networking, file I/O, text-to-speech is in tech preview. They're all in C++ code. So you have to get these into QML, you've got to wrap them up and expose them to QML. And we have a couple plugin libraries that are available in the SDK. We have our ArcGIS Extras, and then App Studio does a really good job about exposing some of these out in their App Studio framework plugins. And these are basically, like I said, wrappers around the C++ code exposed up for QML developers. And then the UI limitations, I mentioned that, inconsistencies with native look and feel. If you brought up a message box, for instance, on iOS using Qt Quick Controls 1, it really doesn't look like an iOS message box. So there's some things to look out for there. Licensing, this is kind of just worth mentioning. The license model that we would use as app developers is the Qt for Application Development license model. You can get some more information about this on Qt.io. Basically, it boils down to if you're doing Android and iOS development, you're going to need a commercial license. So you can get familiar with what that is off of the Qt company's website. So definitely go to the Qt company's website to get the framework and kind of read up on their license model. And then to finish it off, like Mark did, we got some pros and cons. You got same modules, same code, same workflow, same IDE, same look and feel that you can acquire with Qt, access to device sensors, the typical stuff you'd get with a native framework, and a nice open source community. But to summarize, we had the incomplete native APIs common extraction APIs for iPhone and SDKs are missing in some cases, like I mentioned, AirDrop API or maybe keychain access on iOS. Look and feel, the native platform is a little bit lacking, but with Qt Quick Controls 2, that's on purpose. Qt Framework can increase app size a little bit because you're bringing along some of the libraries from the Qt Framework. So that's it for me.
Great stuff. Great, thanks, Mike. Actually, I was just going to, while he's transitioning over, just a real quick question there. I heard a couple of photographs taken over here. So is there some folks that are looking at using the Runtime SDK for Qt in the near future over here? Anybody? A couple of them? Okay. Evaluating? Okay. While you're at the session, right? Trying to make a decision. It's good to hear. Good stuff. Okay, so next up, we've got Morten to cover .NET and Xamarin. Great. Morten, take it away.
Thanks. So .NET, I hope you're all aware at this point, it's become quite cross-platform. You can pretty much run .NET anywhere these days, especially with called .NET Core. And some of it is running on this technology called Xamarin, which originally came from an open source implementation of .NET called Mono. And later, .NET Core has also made their own open source version that compiles with Linux and Macs, can run on small devices, and so on. So I mentioned it's based on Mono, and we only at this point run on Android and iOS. Xamarin can actually run on Mac and Linux, and I believe a few more is coming. Tyson, for instance. But we're currently at this point in the .NET runtime, we don't support this at this point. But that might be something we could be adding later. And one of the things you get with Mono or with Xamarin, one way to think of it, it is C# for Android and C# for iOS. So it's just a different language, but you code against all the native APIs that are available on the platform. So that's like a little bit in contrast to Qt, that is more of a big expression layer, and you never touch the native APIs. Xamarin actually goes straight to the actual API, so you get the full power of the platform, but you also have to write a little more platform-specific code. However, with Mono, you also get all the standard .NET libraries like HTTP client and math and all those things. So you actually have huge amounts of your business logic. You just use the standard .NET libraries and are able to do all your code cross-platform. So when you need to do something platform-specific, you can also do that. So for instance, something like Bluetooth is a good example. Bluetooth is very different in each platform. You'll have to write, if you want to use Bluetooth, you can't use a common API for that. You have to write it for each. I do actually believe there might be some libraries out there that try to abstract that away from you that you can use, that are available usually on NuGet, that you can use for stuff like that. UI is exceptionally different on each platform, so that's something we would design the UI on each platform. But there's also something like Xamarin Forms that is then an abstraction on top of Windows UI and Android and iOS that gives you a way to create UI that works everywhere. So you can actually write your entire app cross-platform with the same code and the same UI code. But of course, Xamarin Forms is a bit more of a least common denominator, if you will. So it might be a little more limited. You might not be able to get as pixel perfect apps as you want if you're using the native UI, and I'll show some examples of that. But it's actually pretty powerful definitely for some simple apps, or even you can mix and match. You can do some pages with just some simple UI. You might want to use Xamarin Forms. Then if you want to get to the bare metal of the platform's UI, you can also do that. So that's actually a good alternative. And I think the Xamarin Forms, or the Xamarin session yesterday, they actually showed kind of a mix and match. So basically what we have in the .NET piece is we support WPF, good old WPF. We also support the newer Windows Universal app. This is basically a more modern version of WPF, if you will. Some slightly different XAML, but not very much different. And then, of course, Android and iOS, and then we have this Xamarin Forms thing that sits on top. So again, all your business UI is the same. You can write view models and reuse the same thing, which is really powerful. And then you can, if you want to just create one single UI, you can use the Xamarin Forms piece. I actually have I like this little zoomed-in view of the runtime for just the .NET piece. Rex had a slide that's kind of similar. This is just focused on these. So we have this big C++ core that spans all the different platforms, and the underlying operating system is quite different. And then the blue box there is basically all ours, and also the yellow box is completely shared in our piece. But of course, the C++ is more or less also completely cross-platform code. So we don't actually write very much platform-specific code. But what powers the C# piece for the .NET piece to it is actually quite different. On WPF, you'll be using .NET Framework. In the universal apps, you'll use a .NET Core. And on iOS and Android, it's actually running on top of Mono. So on top of that, we actually have these UI pieces that are completely different. There's completely separate implementations for WPF, UWP, iOS, and Android. iOS and Android, for instance, sits on top of OpenGL, and on Windows we use DirectX. But also the way the whole view is defined is quite different. The API that we define is the same, that we add to it, but the inheritance is quite different. Like in WPF, we, for instance, inherit from control, and in the iOS, we inherit from UI view. So we do get inherit different behaviors there. So on top of that, we also create the Xamarin Forms. It's not supported in WPF, but it basically abstracts those native controls out. And what Xamarin Forms really does in the specific cases, it really just goes and redirects to the individual platform controls. So when you create a Xamarin Forms map view, it really, on Windows, will create a UWP one, and iOS will create an iOS one. So it really just injects the other one. And that's actually really powerful because the same thing does with, let's say you create a button. It might be a Xamarin Forms button, but on iOS, it's really an iOS native button. And it will have the look and feel of a native button. The same thing on Android and Windows. So you kind of for free get this very native look and feel for it. So the app might actually look a little bit different on each platform, but you also get it feels like an app that belongs on the platform. That could be good and bad. You might actually want the app to look the exact same, and it might take a little extra work. So here's just a much more simple view of it, if you will. But let's look at what that looks like. So I have a little app here. This is pretty typical if you create a new app today, what this would look like. And here's my little project. And then what I've highlighted up here is actually is what's called a shared project. It's basically just, think of this as a folder of code that I want to reuse everywhere. So this is basically this whole section right here. And all it does is each app you see below is a platform-specific app. For instance, a normal WPF app here. And it's just really just saying, hey, let me import all that code in there. And let me code it in here. So it's almost like duplicating the code, except it's just the same file, right? So it's just being injected into each app. So in many ways, I can actually share it. So I share the code because it's a single file, but it's just referenced in over and over and over again. So there's really 4 apps being built right here. But it still gives me power of reusing my code, which is kind of the benefit here. And you will see a lot of here's my view model. And there's not really anything platform specific until I get a little bit deeper down. Here's something I have to do in the UI thread. And the UI thread is quite different in each of them. And I can still do that with these if instances, where I can, based on which platform I'm on, I can actually switch around. And this became exceptionally important. I have some animation code in here that tries to get hold of the pulse of the screen every time. So 60 frames a second, I want to get notified so I can do animation. And that actually gets extremely platform specific. So on Android, there's something called a time animator. On iOS, they use something called a display link. And in .NET, we use this composition target rendering in WPF and UWP. It's quite different, but that's actually, it's the power of Xamarin is really you're just coding against the native APIs, and then you have some .NET APIs that works across. So that's in contrast to Qt. And again, Qt have abstracted a lot of these things away from you. So you just write one code once, and that's great. But if you want to really need the power, not everything has been abstracted away in Xamarin. So it's a pro and con, if you will. So here, just to show, everything I do is actually in Visual Studio. And you'll see, like currently over here, I've highlighted my iOS. It's selected as the active project. And I will actually see, I'll get a whole selection here of all my devices I can run on. I can run a device. I can run on all the simulators. And it's actually coming because I'm connected to that Mac that sits down here on the stage, far away, where I like to have my Mac, where I can't see it. I'm not a big Mac fan. So it really just acts as a build host. And what's really cool is actually when I run it, I can actually bring the simulator back over on my screen and sit and work with it here. So here's that app running. I can actually do pinch zoom on my screen, which you can't do in the Mac simulator because they don't have a touch screen. So that's really cool. So I can just sit in Visual Studio and do all of it. And you can build this app on the Mac too using Visual Studio for Mac. I also have, just for fun, let's say, here is my, let me just sign in. So here's actually the app running on Android, and I should have it on Windows too. There's actually quite a lot of, this is all the planes around the world flying around right now. And it runs great on all the platforms. And this is really essentially the same, but I use a lot of code here to connect to this socket, download all this stream coming in, parsing all that. There's a bunch of JSON coming in constantly. Currently about something like a little over 100 messages a second. And there's a lot of network code, a lot of stuff that I didn't want to write over and over again. And I didn't write it over and over again. So here's actually my, my network code. And I believe there's not really any platform-specific code in here at all. Nope. This is all, oh, let's leave just one more here. Actually, I didn't really need that. I could technically have made this work on Windows too. But all of this is completely cross-platform. And that was actually a lot of work figuring out how to talk to the server, parse all the data and stuff, and I could just reuse that straight up. I do have a Xamarin Forms version here. So here I actually have, I still have these 3 project heads over here. All these apps do is their default app that says, launch the Xamarin Forms app. That's all they did. There's no extra code in there than that. But in my common project, I actually have a page here. That's a XAML page, just like you do on Windows, but it actually runs everywhere. So here you see XAML, like more or less as you know it. Things are slightly different. For some reason, a text block is called label, but the concepts still apply with binding and so on. And I still have the same code. I'm using a slightly different project style over here. This is not a shared project. This is called a multi-targeting project. And it actually, it basically compiles it for each platform. So when you hit build, it'll build it 3 times, one for each platform. And just packaged up in a nice little package that you can then reference in each app. And so it'll actually deploy the right DLL when you want to. So we expand the dependencies. You'll actually see, oh, I can drill all the way down and see what's going on. So for Android here, I expand it. You'll actually see how, here's the forms package that I'm referencing, which is actually referencing Android, where you can see the DLL is inside there. There's actually a DLL inside. In the end, it actually doesn't become a DLL. It becomes a SO file, if I believe, on Android. So the compile tools takes care of all that and compiles it into a proper native app. So that's how that works. Let's see. Let's set this one as. Actually, you'll see up here I have a drop down that shows my Pixel phone because my Pixel phone is connected, so it actually shows that and it uses underlying actually the Android tooling for that. I believe that's actually the GWP app. This is actually the Forms app running on the Windows app. And I get all the debugging tools, even though it runs over on a phone or on the Mac, I can still debug, set breakpoints, all the stuff I'm used to in Visual Studio, which I think is super cool. So there's pros and cons. Some of the pros, Xamarin is actually pretty cheap. It's free. It didn't used to be, but it is now. You do have to be aware of Visual Studio might not be free, so just be aware of that. And one of my favorite things is I can just sit in Visual Studio all day. As I mentioned, you can sit in Visual Studio Code on Mac and do iOS and Android. You can't do Windows over there, but you can actually do a lot of it over there. And they have the full access to native APIs. Every time Android and iOS releases a new SDK, Xamarin is out usually with an update the same day with all the new APIs exposed. It's quite impressive. But the way they do it, actually they can auto-generate the C#, it's called the bindings, auto-generate them from a native library. And if you ever, for instance, see a really awesome iOS library that someone wrote, it's written in Objective-C, and you want to use it, you can actually use their tools to generate bindings and call into, which I think is really cool. Some people actually used to do that with our runtime for iOS and Android. They generated the bindings and called into it, was able to actually make that work. But it did mean that because the iOS and Android SDK were slightly different naming guidelines, they couldn't actually reuse the code. They would have to create an abstraction layer on top, which we now did for you. Some of the cons is you can't always abstract everything. Platform code, it gets quite specific. There's actually similar things that Java struggles with, like your paths might be quite different. And where you can actually get at data. So disk I/O is typically one of the bigger things you see that you're going to deal with first that's different. The Xamarin tooling, especially when it comes to the Android piece, I do find slightly buggy. Sometimes it just won't work, and you come in the next day and it works again, and you didn't do anything. That can be quite frustrating, but I do feel like it's gotten a lot better to do that. And honestly, it doesn't actually, I don't think it's like the Xamarin tooling, it's actually the underlying Android tools that seems to, that whole link doesn't always seem to work right. But for the most part, it works. Especially if you use a device, the emulator seems a little more flaky. And if you want to do iOS development, you also have to get a Mac. So you can't just sit on your Windows. You do still need a Mac just to compile and deploy. I guess Mac wants to sell you the apps. They don't want to bring the tools over to Windows. So that's kind of a requirement. So that doubles the price. But it says you can always just buy a Mac if you don't care about Windows at all. So yeah. Oh, that was not my slide. Sorry. You have a different slide. Unless there's questions, of course.
Good stuff. Thanks, Morten. So just wanted to wrap up just with a reminder right at the end here before we go to questions. So first thing, just to keep in mind, we just looked at the Runtime SDK for Java, Qt, and .NET. Obviously, these are 3 runtime SDKs that we promote for cross-platform development. One thing to keep in mind here is that with Runtime, in the new generation of Runtime, the 100.x release of Runtime, we have basically feature equivalents across all Runtime SDKs, right? We're working with a synchronized API, so the API matches, right? Which means that really choosing a Runtime SDK is not really the question here. All Runtime SDKs have the same functionality, right? So it's not like you're getting something extra in .NET that's not there in Qt or vice versa, right? So it's key to keep that in mind is that although we have multiple products, all of those products are built on the same common core, same common set of functionality, right? So it's not really a question about getting something extra as far as runtime is concerned. So just a parting slide here, just something to think about, knowing that runtime is the same and built on the same common core and built to use the same common native core, then really what you're looking at when you're choosing a native cross-platform solution is, well, which platforms do you need to target? Right? What are your users asking for? Just kind of reiterate. And then basically once you know the target platforms, which developer technologies support those platforms, right? And then basically when you choose a set of developer technology, or you find a set of developer technologies that will support those platforms, the following question is, do you or your staff currently have the experience that's necessary to leverage those platforms, those developer platforms, developer technologies? Now in that case, you get to evaluate whether or not you have the staff with the experience necessary to be able to choose a platform that already supports a cross-platform experience. Or 2, you might actually look at using multiple runtime SDKs. It really kind of depends on the platforms you need to target and the experience that you have on staff to be able to, or staff that you need to hire to be able to make sure that you can build out these solutions, right? So obviously the key here is you're looking for a balance between the highest productivity, being able to consolidate as much work as possible at the lowest cost, right? So that's the ultimate question. And that's what you're looking to solve actually with really a cross-platform solution ideally. So with that, I think we've got about we got 7 minutes left. Actually, it's a lot of time, actually. So with that, we'll go ahead and take questions. Anyone have any questions thus far on what we've seen? Good stuff. Any questions on, oh, here we go, sorry.
They already did. I'm pretty sure Xamarin Form support is there for macOS. If not, it's in the preview builds. I actually can't remember exactly. So we could support Linux and Mac if we wanted to. The thing that's why we're not doing it is, to be honest, no one's really asked for it enough. So it's a huge extra testing effort for us.
I know I asked that another guy, but I think it's because users have not really thought about it. I think when users have not Mac.
Right.
Right. We haven't. I have to admit, we haven't actually seen much of many requests for building applications, native applications on a Mac. I think we thought we would have that. It's probably our least frequently used runtime SDK right now, just the Mac OS SDK. And looking for opportunities to be able to target. Obviously, Java and Qt support Mac at this stage, and I don't think it's a very frequently targeted platform at this stage either. So we'd like for there to be more of an outcry or really kind of a groundswell to support Mac. We just haven't seen it materialize at this stage.
Engineering-wise, it's not much work for us. Most of the stuff is again portable. It's the testing-wise. It's a huge effort for us to add another platform. So we want to make sure there's enough users that actually wants and gets a benefit out of that, because it's going to take resources away from something else.
Yeah, and again, it's still the same native library, right? So I mean, we already built it. It's just delivering it and testing it and certifying it is
I think
there's a cost.
That's a good point. Like the DLL that we deploy and the Qt deploy and Java, it's the same DLL.
the
There's
same.
a few extra, but it's the core is the same, like literally the same.
Right.
Or it's going to be more the same. I think we have a slightly different, but in update 3, it probably is exactly the same.
Nobody heard that, by the way. It's all. Yeah. Yes, question?
So for Qt and .NET Xamarin, you can put cross-platform for mobile devices, but Java you cannot. In Java, they literally saw.
Right. So for Java SE, that's correct. Right. So really desktop platforms, right? Windows, Linux, and Mac. I think it might be worth mentioning that obviously Java, the Runtime SDK for Java and Runtime SDK for Android actually really kind of share the same source code, actually, right? We're just targeting two different platforms. And so while you can't actually compile from the same source, you can use, basically the APIs are synchronous, right? So you could build a side-by-side representation of, and use your Java skills to be able to build a mobile application for Android in that case, right? If you're looking to use Java skills to be able to target iOS, I'm not aware of a technology that does that right now. Are you aware of anything? Okay, good stuff.
It's just worth saying that if you were smart about how you wrote your Java application, you separated out your application logic, that application logic would work in your Android application as well. So
Right.
it is, we share around about 70% of the code base is shared between Android and Java. So it just gives you a feel for how we're building it.
Yep, good question. Anything else, guys? Oh, yes. Yeah, in the back.
When deploying Qt on Android, what is it about that deployment that forces you to use non-LGPL licenses?
So the question is, when you use Qt on Android, what forces you to use non-LGPL code?
Why do you have to get a license for it?
Why do you need a license? Okay.
Yeah, I actually really don't know the Qt business model enough to answer that question. However, I don't think it's necessarily the code that's the problem or the dynamic library that's the problem. It's the fact that you plan on commercializing that product. Unless you plan on open sourcing your code yourself, then you're fine. But if you plan to make money off of that product, you're going to have to get a license for Qt. So it's not the code, it's just, how you're going to monetize your app. We actually have a Qt company representative here, so I hope I answered that correctly.
Anyone from the Qt company in the audience? Oh, there we go. Hey, good stuff, front and center. There you go. Nice. Good deal. All right. Any other questions, guys? Okay, if you have anything else, feel free to come up. We can answer your questions. Other than that, though, thanks for coming to the session, and have a great party, actually, at this point. So thanks, guys.